This is how to integrate functions by parts. In indefinite integration, we opt to this procedure, integration by parts, if the functions cannot be integrated using basic formulas or even trigonometric transformation. In this method, we have to integrate the product of two parts. The first part is the function u, while the other is the derivative of another function v. And this is equals to u times v minus integral of product of v and derivative of u. The function v is obtained by integrating the derivative of v, and du is obtained by deriving the function u. To better understand, let's solve these examples. Number 1. Evaluate the integral of natural logarithm of x dx. If you already viewed our other videos, we already used this formula, that the integral of ln of u du is equals to u ln u minus u plus c. We can derive this formula using integration by parts. Okay, the product of two parts that needed to be integrated is the natural logarithm of x and the dx. We assign u equals to ln of x. Let's solve for its derivative, and that is dx over x. Now for the derivative of v, this must be dx. Integrate this one, and we get the value of the other function v equals to x. In here guys, we don't have to put the constant of integration because we're not finished integrating yet. We still have to use the formula for the integration by parts. Now let's use the formula, that is integral of ln of x dx is equals to uv, that is, ln of x times x minus integral of v du, that is x times dx over x. Copy x ln of x and integrate dx. So, we just solved and derived the above formula. Next is, evaluate the integral of y times quantity of secant y squared dy. Let's solve this using integration by parts. By investigation, since we have formula for the integral of secant squared y, we must assign this as derivative of v. From the given, we use u equals to y, derivative of this is dy, and again, dv is secant squared y dy, integrate to solve the value of v, and that is tangent of y. Let's use the above formula. That is, equals to y tangent of y, minus, integral of tangent y dy, is natural logarithm of secant of y, then, plus c. For the third item, integrate y times ln of y dy. Important tip, in dealing integration by parts, it is best to determine first what are the two parts, u and dv. Assign u equals to y, its derivative is dy. Then, dv is equals to ln of y dy. Integrate to get function v, that is y, ln of y minus y. From the formula, substitute all the values. As you can see, we can combine this too, so we don't need to integrate that again. Simplify. And this is our answer. Let's try another solution. What if we interchange the u and the dv? This we use u equals to ln of y, then the derivative of u is dy over y, and dv is equals to y dy, and v is equals to y squared over 2. Use the formula again, substitute the values. And here, we get the same answer, but with less complicated solution. For the last item, integrate secant of x tangent squared x dx. Important tip, is what we've learned from the last problem. We must assign values of u and dv, that would result to less complicated values of du and v, respectively. Let's use tangent of x as our u, its derivative is secant squared x dx. dv will be secant x tangent of x, integrate this, and we'll have v equals to secant of x. Use again the formula. Here we use one of the trigonometric identities. And here is our answer.